This is video 2 for lesson 4 in Unit 8, Strong Acids and Bases. So in this video we're going to continue our example problems. So what are the pH and pOH values for a solution made by dissolving 13.75 grams of strontium hydroxide in water to make 2.75 liters of solution? So strontium hydroxide has a formula of SrOH2. So we have two OHs in this compound. So we have to find the molarity of the strontium hydroxide and then of the hydroxide after it ionizes. So if we start with our 13.75 grams of SrOH2, we know to go from grams to molarity, we first have to go to moles. So there are 121.64 grams of SrOH2 in 1 mole. Then we're making 2.75 liters of solution, so that has to go in the bottom. So when we do our calculation, we end up with 0.0411 molar SrOH2. Since there are two OHs and this fully ionizes, we're going to get 2 times the molarity of OH minus. So I'm just going to multiply that by 2 for the 2 OH minus ions. And I'm going to have 0.0822 molar OH minus. So that is our concentration of OH minus. That's not what we're asked for. We're asked to find pOH. So pOH is equal to the negative log of that value, 0.0822. And that gives us 1.09 for our pOH. Now the relationship between pH and pOH is this equation. So all we have to do is substitute in our pOH. So pH plus 1.09 is equal to 14, which gives us a pH equal to 12.91. So there is our answer for that problem. Here is our next example. Now we have NaOH and KOH, and we're given gram quantities of each, and we're making 4.59 liters of solution. So this is a mixing problem. So with any problem where we mix, we know that we can add moles together, but we can't add molarities together. So if we think of this, they both have OH. We can find the pOH and then the pH of the solution. Both of these have one OH, so however many moles we have of each one, we can add those together because however many moles of NaOH we have, that's how many moles of OH ion we have. So we're going to start with 25.9 grams of NaOH. We're going to convert that to moles. So 1 mole of NaOH has 40.00 grams. So that gives me 0.648 moles of NaOH, which when ionized gives us 0.648 moles of OH minus. I'm going to do the same thing with our KOH. The only thing that really changes are the amount that we're given and its formula mass. It's a little bit higher than NaOH. So that gives us 1.29 moles of KOH and 1.29 moles of OH minus. So I'm going to add these two together. .95 moles of OH minus. The K and the Na don't matter because they're spectator ions. They're just going to be floating around in there. So now we can calculate the molarity. 1.59 moles of OH minus are going to be in the 4.59 liters, which gives us 0.423 molar OH minus. So now we can use one of our equations for POH. POH is equal to the negative log of our OH minus concentration, which is 0.374. So the pH plus 0.374 is equal to 14 gives us a pH of 13.63. There is our answer. If we look at our next problem, find the pH of a solution made by diluting 10.0 milliliters of 12.0 molar HCl to a volume of 2.50 liters. Here's our M1V1 equals M2V2 equation that we used last unit. So here is V1 and M1. Here is V2. We're going to be looking for M2. But our liters do not, or our volume measurements don't add up, so we have to change this to 0.0100 liters. So if we put in our values, and we calculate our numelarity, we end up with 0.0480 molar HCl, one H in here, so our H3O plus concentration is 0.0480 molar. And to find the pH, we take the negative log of that. So we end up with 1.32 as our pH. And now our last example problem. We are told that a solution has a pH of 7.90. We want to find the pH of a solution that has an H3O plus concentration that's 6 times stronger, and then find a pH of a solution that has an OH that is 12 times stronger than this solution. Now remember that the pH scale is a base 10 scale. So we can't just take and multiply that by 6 or multiply that by 12. So we have to use our equations to find one H3O plus and then OH minus, and then multiply those out and then find the pH again. So our first one that we're going to do, so this is number 1. We know that H3O plus is going to equal 10 to the minus pH. So that gives us 1.26 times 10 to the negative 8th molar H3O plus. So once we have that, now we can find an H3O plus that's 6 times stronger. So all we have to do is multiply that by 6, and that gives me 7.55 times 10 to the minus, I can't read my writing here, it looks like 8th molar H3O plus, and then take the negative log of that, because our pH would equal that. And we get a pH equal to 7.12. So it really didn't get down all that much. Now, if we want to go with OH, we could do POH is equal to 14 minus our pH, because pH plus POH is equal to 14. So we get a POH equal to 6.10, and then we could find the OH minus concentration from that by taking 10 to the negative POH. So here is our OH minus concentration. Now, if we want to find the pH of a solution that has an OH 12 times stronger, now we're going to multiply that by 12, and we're going to get 9.53 times 10 to the negative 6 molar. We can find the pOH of that one by taking negative log of 9.53 times 10 to the negative 6, and I get a pOH of 5.02. And then by knowing that pH plus pOH is equal to 14, I can substitute in the 5.02 to give me a pOH equal to 8.98. And there is my answer. So you are good to work on the worksheets in the Lesson 4 folder on Schoology.